Students, today we are going to learn about light, first chapter of your physics in 10th grade. So in this video, you are going to learn about laws of reflection, different type of mirrors, different type of images, terms being used in the chapter, and the various rules to draw ray diagram. So let's begin with the chapter. We all know that light is a form of energy. It enables us to see. An object reflects the light rays that fall on it. These reflected rays are received by our eyes and make us see the object. Light travels in a straight line, which is called rectilinear propagation of light. Now, in this figure, as you see, the sunlight is coming as straight lines. If you observe over here, so let's change the color of this pen. So they are coming straight lines over here, if you can see. Now, these straight lines are the light rays which are coming from the sun towards the earth, and they don't need any medium to travel also. If you see, they're coming from vacuum and entering into the atmosphere, and they're reaching to us. So they do not need any medium to travel. So light does not need any, light rays do not need any medium to travel. And the propagation of light in a straight line, or movement of light in a straight line, is called as rectilinear propagation of light. This is one of the property of light. Now, how this light is helpful in seeing the object. Let's say a person is standing over here. Let's say a person is standing over here and there is an object. Let's say it's a ball. Some kind of ball is being lying over here. This is the light source. So light is coming on this object, kind of parallel rays are coming. Okay, so these are kind of parallel rays being coming. So these rays will be reflected. These rays will be reflected. Now when these rays will be reflected, and it suppose they fall on the eye of an observer, so that person is able to see the object with this help. So if you see, the light is falling on this object and is being reflected and is entering into the eyes of the observer. So the observer is able to see that this is a ball, and he is able to see the color and everything in that object. So light, this is how light helps us to see any kind of object. Now, if this figure also, if you see, there is a mirror kept over here. What is this? It's a mirror being kept over here. This girl is holding a mirror. This boy is putting torchlight on this mirror. This boy is putting this torchlight on the mirror, and these lights are being reflected. If you see, the light is being reflected, and you can see that spot, this spot of this light over the shirt of this boy. So now here, if you see, what is being happening over here, light is falling on this and bouncing back. Same thing happens here. Light is falling on this and it is bouncing back. It is bouncing back, but at a different angle. It's going in different direction. The what is this thing called as? This is called as reflection. This is termed as reflection. So reflection of light, the phenomenon of bouncing back of light rays in the same medium on striking a smooth surface. The phenomenon of bouncing back, the light rays are bouncing back in the same medium, means they are not passing through this medium, they are coming back in the same medium after striking on this plane surface. Clear what reflection is? The bouncing back of the light rays into the same medium only. Now, let's talk about laws of reflection, which is very important. So for understanding laws of reflection, we have to take a highly polished surface. We take a mirror as shown in this figure. If you see, it's a mirror. Now, in this mirror, if we see over here, in this mirror, this ray, the ray means this is a light ray. The light ray which is falling onto the mirror, that's called as incident ray. The light ray which is coming towards a mirror, we call that as incident ray. And the light rays which is bouncing back, so light ray that is bouncing back. We call that as reflected ray. It is reflected. Now what is this line? Normal. This normal is basically perpendicular line. Okay, this is perpendicular, and it's perpendicular to the mirror surface. It is perpendicular to the mirror surface, meaning it's making an angle of 90° over here. Okay, now all these rays, incident ray, the normal and the reflected ray, they all are in same plane. What is the meaning of the same plane? Means they are on the same side of the mirror. Okay, now what is happening? This incident ray is coming and this reflected ray is bouncing back, and if you see this angle, angle I and angle R, angle I is angle of incidence, angle I is, this is the angle of incidence. It's an angle between the normal, let me just write also, it's an angle between normal and incident ray. It's an angle between the normal and incident ray. And then you have angle R also. Angle R is angle of reflection. That's angle of reflection. This is angle between normal and this is angle between normal and reflected ray. Reflected ray. Both the angles are same. Both the angles are same, meaning, let's say if incident ray is falling at an angle of, with the normal it's making an angle of, let's say this is 60°. Okay, so this angle will also be 60°. Clear? This is what the first law says. First law says that angle of incidence is equals to angle of reflection. The first law. Second law is that incident ray, the normal to the mirror at the point of incidence, and the reflected ray, they all lie in the same plane. So these are the two laws which are applicable to all type of reflecting surfaces, meaning maybe the plane mirror or the spherical mirrors also. Okay, let's observe this thing. Let's take a plane mirror. This is the normal. Okay, this is the mirror. I'll write it down. This is the normal. Now let's say an incident ray is coming over here. What is this? The ray of light is incident ray is coming, and how will it be reflected? This is the bouncing back or the reflected ray. So this is I, this is R. Clear about this thing? Now laws of reflection is done. Now let's move to another point. Let's say image. Now you would have seen your image daily in the mirror in your house. Yeah. So let's talk about what an image is. If light rays coming from a point after reflection meet at another point or appear to meet at another point, then image of first point is formed at the second point. Understood or no? Like from a point, some rays of light are coming. Okay, some rays of light are coming from this point. Fine. Now, let's say they are falling on some mirror or some places. Yeah. And then after reflection, they go back. They go back and they appear to meet or they actually meet. So here they are not meeting because they are diverging. So let's say they appear to meet at this point. Yeah. Fine. So at this point, the image will be formed. At this point, the image will be formed. Here it will be formed behind the mirror if you see. Okay. Fine. So this is what is called the image. So an image is always formed when the rays after reflection meet or appear to meet. This is important point to be noted down here. Fine. Now let's see over here. If you see, you can see there is a candle, and um, here the image of this candle is being formed. Here also the image of this candle is being formed, but there is a difference. Here the image of candle, here you see only the flame. Yeah, flame is not in mirror. Yeah, it is not in mirror. It is on a screen. It is on a screen. This is the screen on which the image is formed. And another thing that you observe is it is inverted. It is what? It is inverted, or I can say it is upside down. Okay. Now let's see over here. Here, if you see, there is an image in this mirror. Here, the image in mirror, you can observe. Okay. This is smaller in size also. This is smaller in size. Fine. And it is upright only. It is upright, or we also say it is erect, means it's not upside down, same as the candle only, you can see. So this is, there is a difference in between these two images. We call them as something else. We call them as one, this one is called as the real image. What is this? Real image. And this one is called as the virtual image. So we have two type of images, real image and the virtual image. Let's see over here. What is this real and virtual image? So a real image is formed when light rays from a point meet after reflection. Here also I told 2 points. One is the light rays after reflection meet, or they appear to meet. So based on that, you have two type of images. When the light rays after reflection actually meet, they form a real image. Virtual image is formed when light rays from a point after reflection do not actually meet, but they appear to meet at another point. Then they form a virtual image. Real image can be taken on a screen. You can see over here. We have produced it on a screen. Virtual images cannot be taken on a screen. The images that we get in convex mirror, the images that we get in plane mirror, if you see yourself in mirror, you cannot take your image from the mirror on a screen, plane mirror. So that type of image is called as virtual image. Real image is inverted, meaning it's upside down, ulta. Virtual images are erect. Erect means they're as straight or upright as this object is. Clear? The difference between real and virtual image? Now let's move to what exactly mirrors are. Mirror is a polished surface which reflects almost all light rays incident on it. A mirror can be a surface on which we just, if the light rays are incident on it, they will just reflect them. Almost all. Few will be pass through it, few, most of them will be reflected back. Now you will study here two type of mirrors. There are two types of mirror. One is the plane mirror. The plane mirror that we see daily in our house. It's a reflecting surface which is plane. A plane mirror has a reflecting surface plane. So it is called a plane mirror. This one that you can see in your house. Then another type of mirrors are there which are spherical mirrors. Here the reflecting surfaces are not plane, they are spherical in shape. The most common type of spherical mirrors are curved mirrors. The one is the concave mirror. This is like this, in which the reflecting part is a little inwards. It is inwards. Okay. Then is the convex mirror. You would have seen convex mirror on the roads or in your societies also, during the blind turns you see there the reflecting surface is bulging out. It's outwards. Okay. Reflecting surface basically. So we talk about reflecting surfaces. Here reflecting surface is plane. Here reflecting surface is it's actually pushed inside inwards. Here this is bulging out, the reflecting surface. Clear? So we talked about three mirrors: plane, another is concave mirror, and convex mirror. Plane mirrors are plane, convex and concave mirrors are spherical mirrors. Clear? Let's understand about the images formed by these different mirrors. The images formed by plane mirror, they have some special characteristics. You all know, you would have seen also when daily you see the images virtual and erect. The meaning of virtual is you cannot produce it on a screen, it is inside, which your image will be behind the mirror only. It's erect means it is upright. Size of the image, if you check, is same as that of the object. Size of the image, if we check, It's exactly the same. Then the image is laterally inverted. What's the meaning of lateral inversion? That the phenomenon of left side appearing right side and right side appearing left on reflection. If you check over here, this is the right hand of the person, but in an image, the right is shifted over here. This is the left hand. Okay. So this is called as lateral inversion. Another thing, the image is formed at a particular distance. Let's say we say this is around 1 meter. So this distance also will be 1 meter. So the total distance between the image and the object is 2 meter. Okay. So the image formed is far behind the mirror as the object in front of the mirror. So the distance between the object and the mirror is same as the distance between image and the mirror. Clear? Now, what are the uses of this plane mirror? Plane mirror we see as looking glasses, which daily we use it. Also, it is used in making periscope. Periscope is being used in submarines. If you see, it uses the concept of double reflection. Then you have seen kaleidoscopes when you play. So they are using the concept of multiple reflection, in which you have multiple mirrors being over there and they're multiply reflecting the same image and giving you a kind of pattern when you see it. Okay, so I hope this is clear. Now let's move to spherical mirrors. Now we have different type of spherical mirrors, concave and convex, two only. So if we talk about what they look like, if you have a spoon, you daily see spoon at home. So the the part which is inwards, that's a concave mirror. That is what? Concave mirror. And the part which is bulging out, that's a convex mirror in a spoon. Try to look at your image in the spoon. You will understand also. Now, let's talk about what exactly is a concave mirror. A concave mirror is also called as a converging mirror. Concave mirror is also called as a converging mirror. It's a spherical mirror whose reflecting surface is curved inwards. It is curved inwards like this. So this part is non-reflecting. The reflecting part is this one. So this is curved inwards. Inwards. The surface of a spoon curved inwards is a concave mirror. Why it is called as a converging mirror? Because it converges all the parallel rays that are coming from any object. You see, all parallel rays which are coming from an object, they after reflection they all meet at one point. They all converge at one point. They are all converging at one point. So it is called as a converging mirror. Then comes the convex mirror. So convex mirror, we see here the reflecting part is bulging outwards. This is the reflecting part. The reflecting part is bulging outwards. So all the rays which are coming parallel from an object, they just diverge. After reflection, the rays just diverge. So when they diverge, so we call this as a diverging mirror. So a spherical mirror whose reflecting surface is curved outwards. The surface of a spoon bulging outward is called as a convex mirror. All rays parallel to principal axis after reflection appear to diverge from principal focus. Hence, it's called a diverging mirror. I'll talk about these principal focus, principal axis later on. Just understand what a convex mirror and concave mirror is. So I hope it is clear. Concave mirror, in which the reflecting surface is curved inwards, and a convex mirror reflecting surface is curved outwards. let's let's see over here what is it now. Now these, as I told, that these spherical mirrors are part of a reflecting basically the reflecting surface is a part of a sphere. If you see over here, it's part of a sphere, and this sphere obviously will have a center. This sphere will have a center. That center is called as center of curvature. That center is called as what? Center of curvature. So the center of sphere of which the reflecting surface of the spherical mirror is forms a part. It is not, this whole sphere is not a part of the reflecting surface. Reflecting surface is only this much part. Okay. Center of curvature is also not a part of the mirror. It is always outside the reflecting surface. So in case of a concave mirror, this center of curvature lies in front. In case of convex mirror, it is at the back. And we represented it with the capital C, the center of curvature. Clear? Another term, let's talk about pole. Now this reflecting surface has a center. It has a point at the center. That point is called as pole. The reflecting surface, the center of the reflecting surface is a point called as pole. So if we draw or represent the mirror with a single line completely like this, okay, so this becomes the pole and center of curvature somewhere here will come. Okay, now let's see over here. This is the pole will be there. Yeah. Now comes principal axis. What exactly is this principal axis? Principal axis is a straight line. It's a straight line. I'll just denote it. What is it? Principal axis, which passes through the center of curvature and the pole of the mirror. The line, straight line that passes through center of curvature and pole of the mirror is called the principal axis. And it is normal. Normal means it makes an angle of 90 degree with the pole of the mirror. Okay. Makes an angle of 90 degree at the pole of the mirror. So it's normal to the mirror at its pole. That's principal axis. The principal axis is the line between C and P. When you join CP, you get principal axis. This is, if you see over here, let's focus now. See, now what is radius of curvature? Before coming to focus, let's talk about what is radius of curvature. This distance basically, CP. If I say CP is radius, if you know, because this is radius, isn't it? But we represent here it as capital R because it's a center of the sphere. This is a point on the, it has to be on, let me just erase this one, not over here, I'll write, it has to be, if it is a part of the sphere, completely should go over here only. Yeah. So radius of curvature, the radius of the sphere of which the reflecting surface of spherical mirror forms a part. Distance between pole and center of curvature. That's radius of curvature. Now focal length. Focal length is from here to here. That's focal length. Okay. The distance between the pole and the principal focus. This is the principal focus of a spherical mirror. Okay. What is this principal focus? We'll talk about that also. Fine. So for spherical mirrors, if you see, we have learned few terms. One is called as center of curvature. Center of curvature is the center of the sphere of which the reflecting surface is part of. It is always outside the reflecting surface. Pole is the center of the reflecting surface of spherical mirror. Principal axis is a straight line joining center of curvature and pole. It is normal to the mirror at pole. Radius of curvature is the radius of the sphere of which reflecting surface is part of. Distance between pole and center of curvature. Focal length is the distance between principal focus and pole. Okay, now between this focal length and radius, we can find a relationship. If you see also, radius is double the focal length, or focal length is radius divided by 2. I hope it's clear. Now let's talk about one more term is missing over here. Aperture is written over here. So what's this aperture? Let's see over here. Aperture is this thing. If you talk about a mirror, spherical mirror, this is the spherical mirror, the distance, this distance from here to here. Okay, it's a diameter of the reflecting surface called as aperture. That's called as aperture. The diameter of the reflecting surface of spherical mirror. So this chapter you will be studying aperture, mirror with aperture smaller than that of the radius of curvature. You'll be studying mirrors whose aperture is smaller than the radius of curvature. Now let's talk about principal focus that I was saying. Okay. Now what exactly is principal focus? We will discuss of this principal focus of both the mirrors, concave mirror and convex mirror. So let's see. In case of a concave mirror, we have this thing. The pole is there, F is there, the focus point and center of curvature. Now what will happen? Let's say if parallel lines are coming, the parallel lines from an object are coming and they are falling on the mirror, the reflecting surface. Now how will they be reflected back? See, they are reflecting back through one point. Yes, they are reflecting back through this point. Now, the point on the principal axis to which all rays parallel to the principal axis after reflection converge is called as principal focus of the convex mirror. Clear? Sorry, principal focus of the concave mirror, not convex. Okay, means after reflection they are all converging at one point. That's called the principal focus of the concave mirror. Let's talk about principal focus of convex mirror. Okay, let's take the mirror also. Here, if you see in case of a convex mirror, this is the reflecting part, this is the reflecting surface. Okay, now the rays are coming parallel only. Okay, now after reflection they are going like that, they are going like that, so they are reflected like this. In here they are like this, behind the mirror they just appear to meet. Yeah, now the point on the principal axis from which all rays parallel to the principal axis after reflection appear to diverge, they appear to diverge, they are not actually diverging from this point. So this is called as principal focus of convex mirror. Okay, now let's learn some rules to draw ray diagrams, because you will be doing these rules in all the new using these rules in all your numericals to draw the ray diagram. So let's understand what are these rules. Like how rules means how the rays are coming on the surface of the mirror and how they are reflected back. Okay, either they are coming parallel, or they are coming through center of curvature, or they are coming through focus, or they are obliquely coming. So there are four cases. One, when the light rays are coming parallel to the principal axis, that is the first case that we will study over here. If you see, the light rays are coming parallel to the surface, the light rays are coming, let's take another color, they are coming parallel to the principal axis. This is the principal axis. So if they are coming parallel, so they how they are reflected back, if you see over here, they're reflected back through focus. So let's just see. First, for the concave mirror we will check. We have the concave mirror, this is the pole, focus and center of curvature. The distance between them should be equal, means if this is 10 centimeter, it also is 10 centimeter. Now the ray is coming parallel to the principal axis. This is the incident ray coming parallel. Okay, how will it be reflected? It is reflected back through focus, reflected back through focus. This is the first rule, that when a ray of light from the object is parallel to the principal axis. Now in case of concave mirror, after reflection the ray passes through the principal focus. Let's see what happens in case of a concave mirror. So in case of a concave mirror, pole, focus and center of curvature, rays will come from here, the parallel rays. Let's see the parallel rays, it will be reflected back. It appear to reflect back through focus. It appear here, it appears to reflect back from principal focus. Okay, so here it is diverging. What it is diverging, and here it is converging. Okay, clear? The first rule, that whenever a ray comes parallel to the principal axis, it will be reflected back through focus in case of concave mirror, and it appears to be reflected back through focus in case of convex mirror. First rule done. Move to the second rule. Now when the light ray passes through the principal focus, when a light ray is passing through the principal focus in concave mirror, and it is directed towards the principal focus in case of convex mirror, let's check what will happen. Now, it's opposite. When it is coming through focus, it will be reflected back parallel to the principal axis. Let's check. We have the concave mirror. The ray is coming through focus. If you check, the ray is passing through the focus. It's incident over here. So how will it come back? It will come back parallel. It will be reflected back parallel to the principal, parallel to principal axis. Okay. Now let's check in convex mirror what will happen. We have the convex mirror over here. Okay. The ray is appearing to be falling towards the principal focus. It is directed towards that. So it is directed like this. It is like this only. It's not going beyond that. So this line should be dotted over here. Okay. Now how will it be reflected back? Again, from this surface only it will be reflected back. So it will be reflected back from here only parallel to the principal axis. So in case of concave mirror, after reflection, the ray will emerge parallel to the principal axis. In case of convex mirror also, after reflection, the ray will emerge parallel to the principal axis. The only difference here you have to write it how it is incident. In concave mirror it is passes through principal focus, and in case of convex mirror the ray of light is directed towards the principal. It is not passing through, it is directed towards, because in case of a convex mirror focus is behind the mirror. Okay. Now, let's move to the third rule, which says that what happens to the light ray when it passes through center of curvature. When the light ray passes through center of curvature or directed towards the center of curvature, what will happen? Let's see. Check for concave mirror, the pole, focus, and center of curvature. If you see over here, this is the incident coming through center of curvature. How will it be reflected back? It is reflected also back through the same path. Okay. The ray will be reflected back along the same path. Both incident ray, this is the incident ray coming, and the reflected ray also go back the same path. Clear? Because here what is happening, incident ray falls on the mirror along the normal to the reflecting surface. Okay. So that is why this is happening. Now let's check of the convex mirror what will happen. Here is the convex mirror. It appear to be incident towards the center of curvature. It is coming like that. So how will it be reflected back? Again it will be reflected back through the same path. Okay. So when a light rays is falling towards C, it will be reflected back also towards C, center of curvature. Now the last rule is, when a ray of light is incident obliquely to the principal axis towards pole P. Obliquely means it's making an angle with the principal axis. Okay. So here the law of reflection will be there. If it is making an angle, it is incident at an angle at the pole. Okay. So it will go back also with the same, it will be reflected back also with the same angle. Let's see how it will happen in concave mirror. This is obliquely making an angle I over here. Okay. This is incident ray. How will it be reflected back? This will be your angle R. Okay. This is the reflected ray. So angle I will be equals to angle R. So the ray will be reflected obliquely with the same angle. The incident ray, the reflected ray, they will make equal angles with the principal axis following the laws of reflection. Let's check for convex mirror here. Again, this is falling over here making an angle I. So it will go back also with this angle R. So this is it. We learnt in this video about the rectilinear propagation of light, the different type of images being formed, real image, virtual image, different type of mirrors, plane mirror, spherical mirrors. Spherical mirrors include concave mirror and convex mirror. Then we talked about different terms which are being used to draw ray diagrams, like center of curvature, pole, principal focus, radius of curvature, focal length, aperture. Then we learned few rules to draw ray diagram. So I hope everything is clear. Practice these rules to draw ray diagrams. And then we will start doing ray diagrams of concave mirror and ray diagram of convex mirror, and then numericals problem based on that. This is it for today.